All right, so we're going to continue with object-oriented programming today. We'll probably get into inheritance. Remember that on Thursday, we'll have a special presentation. I'll have somebody with me from the UNL Writing Center, and we'll talk more about the design document, your first draft of which is due this Friday. So just to make sure that we're all following along here, I'm going to continue to draw your attention to the Gantt chart. According to the Gantt chart that I set up, yesterday you should have read and understand the handouts, and I kind of pointed that to you on the assignment thread, that you've got the project overview, then specifically the assignment 2. The project overview is this rather large, it's a large document, and it is a large project. Don't read that, you should read that document, but don't get lost. That's something that you're going to be doing for the next 3 months, not the next 2 weeks. Assignment 2 is only a small part of it, the first part of it. That's what you're going to be doing over the next 2 weeks. And then finally, the design document, exactly what you're going to be maintaining throughout this process. The design document is designed to give you a chance to think about your design, to whiteboard it, to write it up, and to understand it a week ahead of time before you actually have to submit your code for each one of those phases. So it's designed to give you a chance to design your stuff before you actually go and implement it. And you are graded only on the submission of the draft, right? And not how good it is. Only your final draft. That's where we actually grade on how good it is. We're going to give you feedback through the entire process. And that's something that we're going to talk about on Thursday when the Writing Center comes to visit us. If you want to know what we're specifically looking for in that phase 1 draft, I've enumerated it all here. Basically, you need to show that you've read the handout, basically, and you need to describe this fake client and the system that you're about to build and why you're building it. Okay? So make sure that you're paying attention to that. Hopefully you've already read everything. That was yesterday. I'll go ahead and mark that yes, because I wrote it, right? And then today, you should be planning the rest of your sprint, planning the next 2 weeks, how you're going to go about doing this. Now, if you just want to use our Gantt chart, that's fine. There's your plan. But if you've got different plans, I know that I need to give myself some extra time on this one part or whatever. Then you need to adjust this plan and then commit to it for the next 2 weeks. In addition to that, over the next 3 days, you should be drafting that design document. After your lab tomorrow, you'll want to start designing your test cases as well. You're definitely going to want to do that this week so that you can turn them in by Friday, which is worth bonus. If you turn your test cases in 1 week ahead of time, what we'll do is we'll grab those test cases and we'll actually use them in the grader. We'll clean them up in case they're bad so that we're not grading other people based on bad test cases. But if you hand them in and they're good, then that's worth bonus on assignment 2. So keep that in mind. Okay. Midnight this Friday. Right. Yep. And then sketching and outlining your design, which may include coding sometime later this week. Okay. I'm not going to save that. Right. Okay. So back to object-oriented programming here. Last week we transitioned from basic Java into object-oriented programming Java by designing a class. I ran through the exercise of this isotope decay kind of program, and then we made it into a more object-oriented version by creating this class, putting the functionality in that class, putting the representation in that class, and then we ultimately use that class. Objects or classes in Java have identity, a way of distinguishing themselves from other objects. A state, the actual member variables in that class that define what that class is. And then behavior, the functionality or methods that act on that data in that class. We went through basic constructors, and that's what you're going to be doing tomorrow in your lab. You're going to be given some constructors, and then you're going to break those constructors and rewrite your own constructors and use those classes. We also saw copy constructors, which we're probably going to want to use today. But to pick it up from there, when you are designing objects, basically one rule or one guideline that you can follow is that semantics dictate design. Right? When you think about a student, and I've got it up here, what is a student? Well, a student has a first name and a last name. You might also think, well, they've got a middle name and a suffix and et cetera, preferred name, whatever. You can go ahead and put all those things in there when you're designing your objects. You do have to be careful, though. Remember the Yagni Principle, right? Don't over-design, right? So don't over-design. Yagni, does anybody remember what that stands for? You ain't gonna need it. Right? Don't over-design your objects. Design them for what the semantics dictate. If the semantics dictate, well, I need a way to print out their first name and their last name and sort them by their last name, first name. That's screaming out to you. It probably should have a last name and a first name as a string. I identify students as an NUID, which is an integer or a string or whatever. That dictates the design. I also want to track GPAs and sort by GPAs. Okay, well, that needs to be in there too, right? So whatever your design is, the semantics of whatever your object is, what is a student, that dictates your design of that student. But don't go overboard. Don't over-engineer it. Don't, because you ain't going to need it, maybe. Right? When you do need it, then go ahead and throw that in there, right? And the process that you follow is that you break real-world objects or ideas into smaller and smaller parts until ... it is directly representable. For example, a first name is a string. That's a built-in type. Can you break a first name down into even smaller parts? Well, I guess the first initial and the second letter and the third level. That's going way too far, right? Once you get down to where it's okay, just represent it as a string, represent it as a number, you are done, right? Or an object already exists for it, right? So for example, let me go ahead and go back over here to the student class. And one thing that I mentioned last week that we might want to add to this is the ability to track how old they are. In other words, we want a date, right? Oh, the date of birth, right? So private birth date, right? What type should that be, though? Let's follow that same principle. Semantics dictate design. That's a date. Well, what is a date? Let's break that down. It's a year, month, and a day. Today is February 8th, 2022, right? 3 components there. When you've got 3 components that are directly representable by an integer, integer, well, you could do something like this. Private int day, private int month, private int year, right? Except that if you've got 3 things that represent one idea, a date, what should you do with it? Wrap it up and make it into its own class, right? You should encapsulate those things together. Or, and then the second here, is don't reinvent the wheel. If there's an object that already exists for it, just use it. And for that, I'm going to go ahead and appeal to in the Java time library here, a local date. Now, it's called local date because, of course, dates are relative. It is not February 8th on the entire planet. It is a different day on the other side of the planet or wherever you cross the international date line. But that's why it's called local date. Right? Now, I'm going to ask a question here on how does it represent dates? Does it represent it as 3 numbers? I don't know. What's another way of representing time or dates? A string, right? Tuesday, Feb 8, 2022, right? Another way of representing it would be just a single number. I don't know. We'll come back to that. Okay, keep that in mind. What's the real answer here? How does it represent a date? What? Say again? You read the manual? Okay, yeah, go ahead and rip it open. That's what we'll do later on. We'll rip it open and find out. But more to the point, who cares? Right? How does the square root function work? Who cares? I just need to compute the square root. How does the local date work? Who cares? I just need to represent a date. Right? It gets the job done. That's abstraction. That's one of the 4 pillars of object-oriented programming that we'll get to here momentarily. But otherwise, this is also a concept called composition. Right? Generally, you want to your objects are composed of other objects or data. Right? For example, let's come back to this example over here. A string is an actual object, right? It is an actual class that is built into the Java language, right? It is a class. The local date is also a class, right? And again, we'll open that up later. But it is composed of other things. A class can be composed of another class, and that class can be composed of yet other classes. When you've got a class that owns a class, like I've got here, a student owns a reference to a local date, that's called composition. Right? So when an object owns an instance of another object, it is called composition because it is composed of those other things, right? Another design principle that you want to make sure that you're following is avoid the GodAntipattern. Right? So what is an anti-pattern, first of all? Well, a pattern is a good, kind of a good, well, pattern, I don't know, pull out my thesaurus and come up with a different word for pattern, but a good habit to get into. A pattern is, an anti-pattern is just the opposite of that. For example, up here, when we did copy constructors, those are common patterns, right? They are common blueprints and techniques and things that you can use in your code that can be used over and over and over again, right? A copy constructor was not unique to the isotope class that we designed. You could have a copy constructor for students. You could have a copy constructor for whatever object that you come up with in your design. That is a common pattern that you might want to use. An anti-pattern is just the opposite. It's a bad pattern. It is a bad habit to get into. And so the GodAntipattern is a particular type of technique where you take everything and you throw it into one class, right? It's kind of like if you're coming from a C background, not writing any functions whatsoever, right? Don't write any functions. Just go ahead and cut and paste the code over and over and over again if you need it, right? You need to organize things by splitting them out into functionality, into different functions. Likewise, with object-oriented programming, you want to split things out into different classes. For example, what if I wanted to not only support a birth date, but I also wanted to support an address? Right? So what is an address? Again, let's go through this, breakdown. What is an address composed of? It's a street, right, which is maybe a string, so private string street. Right? What else? City, private string state. Maybe a state abbreviation. I won't go that far. And what else? All right, zip code. Now, what is a zip code? Is it a number? The zip code here for us is 68508 here in Shore, except that sometimes it's 68508-0115 if you want to get really, really specific. Other countries do have zip codes. Does anybody know what Canada's zip codes look like? They're split into three, and then they're characters, right? They can be numbers or characters. So you might be tempted initially to say that all zip codes are integers. Is that true? Nope. I'll go ahead and make that into a string. Okay, city, state, zip. Anything else? Spell it correctly. Building number. Okay, we can get really, really specific, right? Directions, latitude, longitude, right? Stuff like that. Again, Yagni. You ain't gonna need it. This looks good enough, at least for what I'm trying to do now. If I ever need to have zip code, have more directions or building numbers or whatever, I can come back and I can redesign it, right? Except what is this screaming out to you? Make it a class. Why? 4 things. Anytime you have maybe more than one, definitely 3 or more things that represent one entity, one idea, one object, put it into its own class. Let me go ahead and collapse this. Come on. There we go. So let's go ahead and create a new, what should I call it? Address? Okay. And I will come back later and redesign it so that I've got constructors and all that stuff. Right now, all I need to do is use it. Private address, address. There we go. Right. Now, how does local date work? How does address work? How does it represent everything? Again, at this point, I don't care. Right? I just need to have it as a placeholder. When I actually go to design that object and implement that object, then I need to ask those detailed questions. But here again, we've got composition. That a student is a first name, last name, and UID, a birth date, which is another class, an address, which is another class. And again, why do you want to do this? For code reuse. Is a student the only thing in the world that has an address? No, a store has an address. This building has an address, right? If I put this into its own class, guess what? I can reuse that all over the place. Anytime that I need an address, I just pull this out. Anytime that I need a local date, I don't have to reinvent the wheel. I reuse it. Code reuse. It's why we write functions, and now it's why we design objects. Okay? Yeah.
Why is it that Eclipse isn't yelling at you for not importing the address class?
Because I put it into the same package. So the question was, why is it not complaining that I didn't import it? Anything in the same package is going to be available already. If I put it into another package, for example, the student here, if I wanted to bring in isotope, right? For some reason that the student has an isotope, private isotope I, right? Now it's going to complain because that isotope class that we were working on before is in a different package, right? Good question, right? All right, so the GodAntipattern would be the opposite of what I just did. If I split out and I didn't create or use a local date object and I put those three elements into this class, if I didn't design an address class and I took all those elements and put it into this class, now it's a God class. It knows everything, it sees everything, it does everything, right? It's omniscient, right? That's why it's called the GodAntipattern. Don't do that. Split things out. It's like writing putting all of your code into main in C. You don't do that. You split it out into functions, okay? So you want to avoid the GodAnti class. A class should only know about its own stuff, right? The address class should only know about address stuff. The local date class should only know about date stuff. The bank account class should only know about bank account stuff. Right? Don't mix them around. All right. So I've hinted about these four pillars, and we've already talked about basically the first two. In fact, they're quite intuitive, and they are even in C, right? Abstraction and encapsulation. What is abstraction? Well, we already know what encapsulation is, but we'll review that here momentarily. Abstraction is implementation or information hiding, right? Sometimes they'll use information, like information hiding, right? So the idea here is that you shouldn't have to worry about how an object is represented, right? Just how to use it, right? That's called its interface. It's publicly facing methods, right? You don't need to worry about how it's implemented. You don't need to worry about how it's represented. For example, how is local date, or how does local date represent an actual date? One answer would be 3 integers, right? For year, month, day. Another idea would be a string, right? An ISO 3306, is it? Does anybody know? What is the ISO standard? ISO 3306 date standard. It's not, no, it's not 3306. ISO date standard, what is it? 8601, there it is. Date and time format. There is a single string that you can use, like this, right? But there are standards for how it gets represented, that it's in lexicographic order, stuff like that. So ISO 8601, right? Let's look at the Wikipedia page on it instead. That'll give us a better representation. There is a typical date timestamp. Year, hyphen, month, hyphen, day. separated by a t, an optional t, and then time, with a Greenwich Mean Time plus a Greenwich Mean Time offset. Right? This is how you can represent dates. Optionally, I think you can also put in a zone at the end, so that we're in Central Standard Time right now, right? We're not on Daylight Savings Time. So this is another way, which would be a string, an 8601 standard. What's another way that is commonly used to represent time? Think about Unix. How does Unix represent time? Do you remember? A single number. Say the number of milliseconds since an epoch. Right? So, for example, the Unix epoch was January 1st, 1970. Right? And so the Unix time, we can probably find out what the Unix time is right now. Unix time now. Right? There we go. All right. Unix time now. There we go. That's what I want. That's the time right now. That's the number of milliseconds, or based upon the seconds since the Unix epoch, which was on a Thursday apparently, January 1st, 1970. To go back in time would be negative numbers prior to 1970. Eventually, we will hit overflow. I think it's 2038, and any 32-bit system that is using that to represent Unix time will then overflow, and it'll be 1902 or something like that, just like the Y2K problems. Don't worry, most systems are 64-bit systems, so we're good for several billion, trillion years, whatever it is. Right? But that is another way that you can represent time. Right? What's the ultimate answer, though? Who cares? Right? So let's go ahead and rip it open and find out, like, if we're really interested in this answer. Local date. Did I have to jump inside this class in order to use it here for the birth date? Nope. Instead, but if I do want to jump into the class, let's go ahead and find out how it represents stuff. Right? Oh, hey, which one was it? It was the three numbers, right? Year, month, and day. Month and day are only shorts. Those are only 2-byte integers, I believe. Why? Because, well, maximum 31 days in a month, maximum 12 months in a year. Right? So it used smaller numbers for it. But that's how it ends up representing the year, or an actual date, a local date. Okay? So it turns out the answer was what we were going to do. But again, the real answer is, who cares? You just want to use it. That's abstraction. Right? How does the square root function work? Who cares? Right? It uses a Taylor series. Does it use some sort of convolution method? Does it use interpolation? Who cares? Right? It just gets the job done. Right? Now, if you actually have some smaller engineering concerns that, I need some sort of convergence property, then of course rip it open and find out what it is and use a different version. But if you're just wanting a square root, just use it. Right? That's what abstraction is. You can simply use it without having to worry about it. Another example, how is time represented? How does Java represent a string? So you did have to worry about this if you're coming from a C background. How is a string represented in C? A character array? Is that all, though? A null terminated character array, right? And that meant that you were responsible for all the bookkeeping. It meant you were responsible for all the details, making sure that if you called a function that there was a big enough memory to hold what you were trying to do, and that you also had to make sure that there was a null terminating character in there somewhere, right? You had to worry about the details. But since switching over to Java this semester, have you had to worry about any of those details at all? Nope. Concatenate all you want, right? Call that function all you want. Do whatever you want with a string, right? You don't have to worry about those low-level details. I wonder, though, how does Java actually represent a string? There we go. As a what? A byte. A byte is a single 8 bits. 8 bits represents a what? A character, right? So in other words, a character array. It's not a char array. but it's very, very similar. It's a byte array. And that's the only difference there between a char array and a byte array is so that it can support Unicode characters, emojis, and CJK fonts and stuff like that. Right? But at the end of the day, it's exactly what you did in C. Right? No null terminating character here, but again, did you have to worry about it? No. That's abstraction. If you build the class, if you design the class, then you need to worry about those implementation details. But the idea behind object-oriented programming is once you've made that object, once you've made that function, right, then you don't have to worry about those details ever again. You've wrapped it up, you've encapsulated it into one logical unit that you can test, that you can isolate, and that you can reuse. Right? Abstraction. And then we could go over a whole bunch of other examples and where you don't have to worry about any of that stuff. Encapsulation, though. And this one is just a repeat of what we've already covered. It is three things. It is the grouping of data into one logical unit. It is the protection of data from the outside world using public, private, protected, stuff like that. And the grouping of methods or behavior that act upon that data. Right? Now, with a programming language like C that is not object-oriented, you only have the weak encapsulation. You only have the first one here. How did we achieve that in C? We created a structure, and we put things into that structure, but we did not have the protection of that data. There was no public keyword. There was no private keyword. If you wanted to change any piece of code that had access to your to a reference to a structure, could change that code. Right? And from a C perspective, maybe we wanted that. But now from a Java perspective, from an object-oriented programming perspective, we want to limit how people interact with our designed objects. I don't want you to be able to set the first name to null or the last name to null or something like that. With a local date, what do you think happens if I try to set a bad date? Local date, D equals local date dot of, right? So 2022, second is, that's the month. And what's the last day of this month? Is it a leap year though? Nope. So the last day of this month is 28. What do you think happens if I try to set it to this this bad date right here? There was an exception. February 29th is not a leap year, right? Okay. Well, what about March 32nd? Right? Is that going to work? Nope. Invalid month of year. Values 1 through 12, 13 was not recognized, right? So this is only possible when you've got protection of this kind of data. You've got validation. You can't even create an invalid date. You could create, with C, like take any old student or a transaction or whatever we did last semester, a film. You can create a film and then change its variables to whatever you want, whenever you want, however you want, right? Because there's no protection of that data. There's no way to protect that data from bad data from the outside world, right? But with strong encapsulation in an object-oriented programming language, we do have that now. And finally, we have the grouping of methods that act on that data. If you're coming from a C background again, everything that acted on a student or acted on a bank transaction or something like that, right? You put that into one library, right? Just like all the math stuff is in the math library. All the string stuff is in the string library. All the bank account stuff, you can put that into a custom bank account library, but it's still not acting on the data. You're still breaking encapsulation by taking that functionality and locating it into its own functions. Right? We did that with our initial version of the entropy program, where we just had this function that lived outside, and we gave it the half-life, the mass, and stuff like that. Then we changed it into a more object-oriented version where we took all that stuff, put it in the class, and so well, where does that functionality belong? It belongs in the class. If it remained outside the class, it means that we'd have to rip open the class, pull out all those pieces of data, put it somewhere else to get our answer, take that answer, and then put it back in the class. Right? That's breaking encapsulation. Make sure that you don't do that. Any function, any method that acts on a class belongs in that class. Otherwise, it's breaking encapsulation. Right? Okay. So don't break encapsulation by locating data or methods that act on that data outside the class. Right? Bank stuff belongs in the bank class, not the main, right, or main method, or demo class, right? Student stuff belongs in the student class, right, et cetera, et cetera. Just ask yourself, what does this method do? Oh, well, it operates on a student's NUID and GPA. Well, where does it belong then? It belongs in the student class, okay? Just ask yourself, where does this thing belong? Don't just locate, throw all of your functions into one big class, because even that is a God class. You might have separated it out into different functions, but you are still breaking encapsulation, and that function still knows about everything, or that class knows about everything, all right? Okay. Questions so far? No? All right. Again, good abstraction and encapsulation. These both work together, by the way. You have abstraction, the idea of abstraction, even without object-oriented programming. You have the idea of encapsulation, even without objects. Even if you don't have structures, you still have modules, you still have libraries where you should encapsulate stuff to where it belongs. Or it's basically organization, all right? Good abstraction and encapsulation work together to make code isolated, right? More easily testable, easily testable, right? Control or limit what are called side effects, right? And reusable. So all these things work together to make your code way more maintainable, right? You want to isolate a functionality because you want to be able to test that functionality. We call it unit testing for a reason. If you don't have well-defined units, right, every piece of code touches every other piece of code, and it's all one big piece of spaghetti code, right? Then you're not isolating anything. It's chaos, and you end up having to test for every possibility. But if you isolate things and put it into one unit, you can go ahead and take that address class and put it through a bunch of unit tests over here and not have to worry about any other class at that moment. Right? Your isotope class, you can go ahead and test that in isolation of all of your other classes. So it's more easily testable. Otherwise, if, for example, you take this to another extreme, there are no functions. In fact, all variables are now global variables. Any piece of code can change any other piece of code, right, or value in the piece of code. Then you have to test for that eventuality, right? And you don't want that. You want to limit the side effects. Just like globals are evil, breaking encapsulation and releasing all of your data to any other piece of data in your code is also evil, right? Globals are evil. Breaking encapsulation is evil. And of course, it makes it reusable. If you don't put something into an address class, then you have to repeat those 4 pieces of data over and over and over again, violating the DRY principle, the don't repeat yourself principle. Right? Okay. So the next pillar, remember we have 4 pillars. Actually, you can say 5 pillars too. But then, have you ever heard of a building held up by 5 pillars? So it doesn't work out. But the 5th pillar, of course, is objects, right? You can't have object-oriented programming without objects. But these are the 4 ideas behind those defining objects. So the next one is inheritance. And to motivate this, for the rest of the day today, we're going to design classes, but then we're going to implement inheritance with these classes. So here's the following scenario. We've got a retail store that we're writing a software system for, okay? And this retail store has some products and subscription services. The products are items that have a price, and a customer may purchase any number of them. So, I don't know, you sell oranges, and you want a dozen oranges. You sell USB memory sticks right next to the oranges, and you want 2 of those, or you just want 1 of those, right? Subscriptions are an annual rate, have an annual rate that are purchased based on a start date and an end date. So, I don't know, you have to subscribe for a PS5, right? PS5, PS Store subscription. What is it called? PS Online, Sony Online. What? Sub Plus. Okay, something like that. Everybody adds that now. Disney Plus subscription. PS subscription. Xbox Online. Is it? Xbox Live. Oh, Gold Live. Okay, whatever that is. And then finally, Switch, Nintendo Online, right? Whatever. It's a subscription. It begins on a certain date and it ends on a certain date. And you've got an annual fee that you have to pay for this that we will normalize to a daily fee. Okay, so that if you only want 2.5 months of Xbox Live, then you could only have to, they prorate it, right? They don't charge you the full year. This is our scenario. Of course, the real companies would be jerks and probably charge you for the whole year even if you don't use it. And make it extremely difficult to cancel this subscription, but ours will be a sensible subscription. You want 2.5 months, great. We'll go ahead and have a particular start date, February 8th, 2022, plus 2 months, and that's how much we'll charge for you, okay? So let's go ahead and start designing these objects. I'm going to go ahead and get rid of these two things first of all. Collapse this one back, right? And let's go ahead and start with a product, right? So a new class. And what should I call this class? Semantics dictate design, so they should also dictate the name of your class. What is it? What is it? Product, right? Okay. Now, what is in a product other than they're items that have a price and a customer may purchase any number of them, right? Okay, so we've got a price and the number of things that you buy is its quantity, right? Excellent. See, naming things isn't so hard. Right? What else is in a product, though? A name, okay. So I'm going to go ahead and make that into a, I'll just leave it like this, name for now. All I'm doing here is whiteboarding, right? And this is how you should be going about your first phase here, especially if you're working with a partner. Have a whiteboard between you. All right, well, this is what we need, this is what we need, this is what we need. Don't start writing code like I'm not even writing code right now. I'm just jotting these things down, right? This is drafting. This is something that we'll talk about on Thursday. When you write an English paper, you don't just start writing, you draft, right? You can just start writing, but that's not what you're going to end up with. And in code, don't just start writing code, draft it on a whiteboard. This is why we call it whiteboarding. If you don't have a whiteboard, fine. Pull out a piece of paper and a pencil and start doing that. Or pull out your iPod and GoodNotes. I use GoodNotes, we'll see it later, and just start writing on that. Whatever technology you use to draft your idea of what a product is, right? Whiteboard it. And if you are teaming up with somebody, make sure that you're teamed up by Friday before you hand in your first draft. And how do you team up, by the way? Because only 4 people have done so far. You join a group on Canvas, right? Canvas, people, and then it's called project pairs, and then you join a pair that is not currently being used, right? If you don't do that, you will not be graded correctly, right? So make sure that if you're teaming up, and we highly encourage that you do team up with one other person, make sure that you're doing that before Friday. Anyway, we like you to team up because you go through this process of whiteboarding. Like the quantity, right? That's a great name. I would have called it number of items, right? Quantity is even better, right? All right, what else? Maybe a description, right? So usually we have some sort of ID, right? So product ID, right? If you go to a store and you pull out the barcodes or it's called the, what is it called? SKU number, all right, SKUs or UPCs, right? Universal product codes, SKUs, right? Is that, no, SKUs, there it is, SKUs, right? Et cetera, et cetera. I don't know what our system will use, but I do know that I want a way to identify it, so I'll go ahead and go with a product ID. Right? That could be a string, that could be a number, I don't know. We'll find out, right? Semantics dictate design, right? At this point, if this was a real system, you'd go back to your stakeholders and say, how do you identify all your products? Oh, well, we use a SKU system, right? Or we use a UPC system, or we have a custom, some guy 10 years ago wrote a custom system so that It was all what are the boxes? I forget. That you can scan. No, well, you can get a URL out of the box, but QR code. Thank you, QR code. Right? Brain fart there for a second. Or maybe the UUIDs, right? Universally unique IDs. Right? I don't know for now. I'm just going to go ahead and go with this. To keep it simple, we'll go ahead and get rid of that just so that I don't have to write too much. Okay? All right, that looks good. Now let's actually start writing our code here. So what is a product ID? Well, it's a string. I'll just say that it's a string for now. Right? Even SKUs and UPCs and stuff like that, they'll all have numbers, but often they'll have a hyphen so that you split them up. Social security numbers will have hyphens in them. So even if it's a number, numerical, you probably still want to keep it as a string representation in a lot of cases. Right? All right, what's a name? String, reasonable. What's a price? I'll make it a double, right? Another way that you could do this is a currency class of some sort, right? So that you keep things general. Just like at first we did our isotope class and we said, all right, well, what is the number of years? After how many years have we, how much of this radioactive isotope do we have left? We then changed that to a more generic duration because not every year is created equal, right? Sometimes you don't want years. Sometimes you want to convert it into days. After how many days do I have left, right? Currency likewise. The dollar is not the only currency out there. Right? What other currencies are there? Yeah, euro, yen, etc. Right? So maybe there's a currency class and there is one built into Java. I won't use it though. I'll just go ahead and keep it as double. Right? But that is a design decision that you might want to think about. Okay. Quantity. Oh. Priceal. Okay. Quantity. What is it? An integer? Okay. Right? And it really depends on the product too, because are you buying by the pound? Is it a liquid that you're buying? Can you buy fractional value things of this? Like some things it doesn't make any sense. Can you buy 3.5 switches? Right? No. Can you buy 3.5 copies of a game? No. Right? So for now, I'll just go ahead and make this into an integer. Right? Now, is this a well-designed class? Nope. It breaks encapsulation. How? It violates the protection of that data. So how can I fix that? By making everything private. In fact, home row, private. And I will also make it all final because I really like immutable objects here. Okay? Once created, it cannot be changed. All right, it's complaining. Why? Because I don't have the rest of my boilerplate up here. How do I create boilerplate? Generate constructor using fields. That's good. Maybe I'll want a different constructor later on. I don't know. In fact, in a couple seconds here, I'll probably want one. And then maybe getters and setters. Do I want to have setters? No, because I made everything final. You can't set it if it's been made final. So generate this. Great. I should have located my cursor down below. Getters usually go below constructors. And now is it a well-designed class? What did I forget? Documentation. I'll put it in a to-do here. Right? What does this represent? It represents a product. Right? Class to represent a product in our point of sale system. Right? Whatever. Good. Okay. Let's go ahead and use this class now. So I'm not able to create this date. I'll go ahead and get rid of that. Let's go ahead and create, give me a product. What? Bananas, okay. Bananas equals new product. And it has an ID, I don't know, B123, right? Or potassium or something, right? Banana. Okay. How much are bananas? There's what? They're $1 a banana? No way. $3? Hopefully that's for a dozen. Okay, so we'll say 25 cents. And how many bananas do you want? Bananas go bad pretty quick, so don't buy a whole dozen for yourself unless you're a banana freak. So 8? All right, there we go. So one person wants to buy 8 bananas. Maybe another person wants to buy 12 bananas. Do you remember the pattern that we followed so that we didn't have to repeat this stuff over and over and over again? Constructor. What kind of a constructor? Copy constructor. So bananas A, or like purchase A, purchase B. Right? And I'm going to create a bananas general. Right? There we go. And I'm going to come back over here to this product. And I'm not talking about bananas anymore. I've jumped into this product class. And I want maybe a copy constructor. So what does a copy constructor look like? I can't generate it. But it takes another product, product P, and anything else that you want, and then creates a deep copy of that thing. So this dot product ID is equal to P dot product ID. This dot name, so much typing, P dot name. Right? This dot price is equal to P dot price. Oh, P dot price. I'll go ahead and get rid of this now so it actually compiles. Right? But we will change that. Quantity is equal to P dot quantity. There we go. Type, 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 type. That looks like exactly the same code as down here. So what did we do to get rid of those lines? I want this constructor to call that constructor down there. So how does an object refer to itself? This. So how does an object refer to its own constructors? Also this. Maybe I didn't show this trick. Just pass all of those in as arguments. And now you're calling that other constructor. Oh, you got to put that in. There we go. No repeated code. Okay. Now, do you want just a straight up copy? When I've got bananas, right, I wanted to put 8 bananas on this one, and 12 bananas on this one. So, do you want a straight copy where you are copying the quantity too? If so, then this is what you want. If you don't want this, if you want something else, then design it. Right? There was a question on Piazza about how do I go about doing this constructor? Write one. Right? If you want a constructor to do something a certain way, write it. Right? Give it to yourself. So if I want a constructor to make a copy of bananas, but with a different quantity, make that into a constructor. And then instead of passing in the original product's quantity, that quantity. Okay? Let's come over here. And now I don't want to say that there are 8 bananas always, but I will go ahead and pass in the other bananas 8 and bananas 12. Right? Now what's the problem with that constructor up there? Did I make it? I've got a constructor that takes a product and a quantity. I've got a constructor that takes all 4 of these things. What I would really like is a constructor that takes these 3 items. Well, if that's what you really want, then what do? Make it. And in this case, I don't have to make it. Generate constructor using fields, everything but the quantity. Generate that, and I'm done. I didn't even have to type anything. Okay. Now, it is complaining about this still. Why? The outside of the class, oh, that's fine. I don't care. Right? But over here in the product class, it's complaining why? That quantity field that we said is final and is an integer was not specified. What is it? No default is provided in this case. So what should I do? Provided a sensible default, right? This dot quantity is equal to 0. An alternative would be me going back and saying, well, wait a second. Sometimes it doesn't have a quantity. Maybe we have an argument here for what's generally called tri-valued logic. Something could be true, false, or I don't know. Well, an integer can have a value or I don't know, which would be capital I integer. In which case we don't set it to 0. Instead we say it's okay if it's null. Right? 0 means that you actually bought 0 bananas. Right? But null means you didn't buy, I don't know how many bananas you bought, period. Right? Okay, what else? Unfortunately, this auto-generated code here, what is, it doesn't look like this. We could make it look like that by, forget about that super for now. We'll come back to that. But product ID, name, price, and null. Right? There we go. What are you complaining about? Okay. Oh, yeah, it's not defined why, because we're not expecting anything that's null. So we have to refactor this a bit and allow it to be null there. And now it's happy. Okay. That's good enough for now. Let's go ahead and switch gears here and try to do the other type of product. Subscriptions. So what are subscriptions? Let's go ahead and go new class, subscription. Tell me what a subscription is. Go ahead. Well, there was an annual fee, right? That was in the handout, right? This thing over here. Subscriptions have an annual rate and are purchased based on a start date and an end date. So semantics dictate design. I should at least have an annual rate. And what else should I have? Start, date, and end date. All right? Okay. All right, so how do we identify that? Subscription ID, maybe? Just like we did with product ID. What else? I heard name, right? Nintendo Online subscription, Xbox Live subscription, right? Whatever. Okay. What are all of these things? This first one sounds like a private final string. The second one sounds like a wait, we got a question online, or maybe just a comment. YouTube recommended this live stream to me. I took this class a year ago. Can't say I miss online classes. Okay. All right, what about annual rate? That's a currency, right? $50 a year. What is Xbox Live? How much is it? 60 a year? That's it? Oh, wow, okay. Now I just need an Xbox. All right, I'll keep that as a double. What about start date? Date screams out what? Local date. Right. Use something that's already there. Don't reinvent the wheel. Right. There we go, there we go. Of course, you will have to import it, and this goes back to your question before. Import java.time, because it's in a completely different package. Okay, same as before. Right? In fact, I'll probably want to duplicate everything that I did over here. All the getters, all of the constructors, stuff like that. For now, I'm just going to go ahead and generate the constructor using the field, or using all the fields, and then I'll come back later maybe and fill in the rest of it. Okay. For now, I just want it to get it to compile. Okay. All right. Well, how much are those bananas? System.out.println. Your banana total comes to, for purchase A here. Well, I need what? The price per banana times the number of bananas that you bought. Okay, there we go. What should it be? 25 cents for 8 bananas is $2? Yep, $2. Format it later. Details, details, details. All right. Is that the right way of doing it? I have some behavior here now. Some non-trivial behavior. How much does this product cost? It's the quantity times the number of, times the price per unit, or the price, right? So, if this is behavior, it belongs into a function. So let me go ahead and try to create a function here. Public static double get total cost, right? Or get cost, I'll say. And it takes in a product, right? P. And it takes this product and returns P dot get price times P dot get quantity. Okay. That's a little bit more satisfying. I will get the cost of this banana on purchase A. At least if it's in a function now, I can reuse that function, right? So on B, A and B, right, I can go ahead and say, there's my purchase on B. $2 and then $3 instead. Right? Still not that satisfying. If you were coming from a non-object-oriented programming language, sure, this is the solution. But this is an object-oriented programming language. That is behavior, that is functionality that acts on a product's price and quantity. Where does it belong? In the product class. So let me take this and get rid of it. And let's go back over to the product class, and let's add some non-trivial functionality here. I'll do it between the constructors and the getters. Right? It's no longer static because it belongs to the actual class. Right? Or to an instance of the class, excuse me. Static means it belongs to the class, that it belongs to product. If it belongs to product, then it has no idea about any of these variables here at all. Right? Because I can have a product of bananas on one purchase and another product of bananas on a different purchase. The class itself doesn't know about those two things. It only knows about the class stuff. Right? So I need to make it non-static. And I can go ahead and call this thing's getters, but should I be given a product anymore? Right? I jumped inside the class. Right? Who am I now? I'm me. But if I'm an object, how do I refer to myself? This, not that. Right? There are two objects here. If I gave you a product, and you're a product yourself, who should I compute the price on? That product or me? Me, right? So that product should not exist at all. Get cost will act on the variables inside this class. This dot price times this dot quantity. Right? And I'll return that value to the calling function. Now what does it look like over here? I'm no longer calling this function that belongs to the demo class, right? This get cost, it gets the cost of a product. It does a product thing. Where does it belong? In the product class. It doesn't belong in the demo class, right? So get cost, now it looks slightly different. Bananas on purchase A dot get cost. Bananas on purchase B dot get cost. Oops, cost. There we go. That's object-oriented. I'm asking each instance, what's your cost? What's your cost? What's your cost? Right? I don't have to rip open the internals of that class, hand it on to some other function. It puts it all together and then gives it back to me. I've got the cost now. I can set the cost. No, that doesn't make any sense. I can just print the cost. Well, I should have asked the product what is its cost. Right? Okay. Any questions so far? Then let's make a subscription and use the same ideas here. Instead of making an initial function outside the class, though, I'm going to start with good programming principle, good object-oriented programming design immediately, and go into this class and ask, what's your total cost? So public double get cost. What's the cost of a subscription? It's the number of days between a start date and an end date, right? Normalized to 365 days a year times your annual rate. Right? So if you have, say, 60 days of a subscription, 60 divided by 365 times your annual rate. Right? So how do I do all that complex logic? this dot start date, I RTM, read the manual on how to use local date. And I think it's until, yep, until end, and then unit, so this dot end date, and then the unit will be, what do you want? Temporal unit dot, I want days. Oh, come on, what is it? I guess I need to import. Okay, it's not days, what is it? Dot. Oh, come on. All right, I'll leave this as a, come back and fix this later on, right? But otherwise, this gives me the number of days. If I divide that by 365, if anybody wants to, they can look this up for me really quick and find out how to get start date until, and then whatever the temporal unit is here, right? Foo, right? Return this times, or this dot annual rate times those number of days. What should foo be? All right, create a local variable foo. Temporal unit foo. Temporal unit dot, and then there's no public. Okay, fine. I forget how to do it. Can't do it like that. All right. It will unsatisfyingly not compile. Right? I'd have to look this up how I've done it before. I don't know. We can do that really quick. We've got a browser over. Java, local date until temporal unit. Example. Here. I want that. Tutorials point. Temporal unit, chrono unit. Of course, it was chrono unit dot days, not temporal unit. Temporal units probably, this is all goes to inheritance as well, that we're getting into right now, right? Even though it might not seem obvious yet. Right? Okay, so get cost. Now let's go ahead and play with it over here. Give me a subscription. Xbox Live, right, is equal to a new subscription, and it has an ID of, I don't know, 345. Xbox Live. Is the B uppercase or lowercase? Lowercase, okay. And then what else do I want? The annual rate. How much is Xbox Live? $99 a year? Okay. Something like that. All right. And then the start date would be local date dot of, and I don't know, 2022. Say that I'm going to purchase it for starting today. It's the 8th. And then I'll go all the way to the end of the year. Local date dot of 2022, 12, and then 31st. All right. So how much is that subscription? Your subscription comes to Xbox Live dot get cost. How much is it? It's only about what, 1/11 or 11/12 of a year, so it should be somewhere about like $90 to $100 or something. Oh, it comes to 0. Why? I screwed up somewhere. 22, 12, 31. Subscription. Start date until end date, days. What did I do wrong? Yeah, I heard the key word there is truncation, right? So let's go ahead and take this opportunity, double x is equal to, and then I'll return x here. Remind ourselves how we run the debugger, right? I knew what I did right away, but if you didn't know what you did right away, there was something wrong with this cost function. So go ahead and set a breakpoint, double click over here, run the debugger by hitting the bug up here, right? It puts you into debug perspective over here, right? There's a little bug over here if you can't see it. And you can see the value of all of your variables over here in this tab right here. So this Well, this is, the annual rate is $99, so that looks like it's good. The end date is 2022, December 31st. The name of this is Xbox Live. There's a start date. There's a subscription ID 354. So it looks like all my constructors were correct. Right? You can break this up into more if you want to, but otherwise, if I keep stepping here, I see that X is immediately 0. So that allows me to focus on this one line. If you want to, you can hover over things and see what it looks like, but it's not actually going to compute this. You can break this out into separate lines so that you can go value by value, find out how many days are there between these things, and then divide it by 365. And at that point, you see that it was 0. And the fix is to make sure that you pay attention to integer truncation. Stop the simulation. Go back to your Java perspective, run it again, and see that it comes out to 88 bucks. Except that $88.42 and 0.19 cents, are they going to charge that? So what should you do? Maybe round it. Not round it to the nearest dollar, because that would be $88. They want their 42 cents. So how should I round it? Round 2 cents. Is there a round to cents function built into Java somewhere? No. So here's an argument for not making something object-oriented. What if we had another class over here called utils? It's a generic utils class. Utils short for utilities. What if I had a public double round 2 cents function? Double X. What would it look like? There is a math.round function, but it works on whole numbers. So how can I change this so that it is rounding to the nearest cent, to the nearest 100th? Multiply by 100, and then correct and divide by 100. All right. What else should I do? Document. Otherwise, I can use it. Now, I can't use it here because it's in a different class. It's in the same package, and I can do what's called a static import, but I would recommend against doing something like that. Instead, you want utils.round2cents. Just like math.round. I had to go math.round because it's in a class. And what are you complaining? What are you complaining about now? It was. Did I make it static? I did not. Sorry. There we go. So there's the difference. Let me undo that. And note here that it will not allow me to call utils.round2cents because if it's non-static, like all this stuff up here, it belongs to instances. It belongs to that banana for purchase A. It belongs to that banana for purchase B. It belongs to that particular subscription. It does not belong to the class itself. By making something static, it means you don't have to have an instance for it. It belongs to the class. So utils.round2cents. And that's why it now compiles down here. All right. Let's run it again. Make sure that it rounds correctly. $88.42. Good. Now, the takeaway from all this is don't repeat yourself. If you're inside the same source file and you see a chunk of code here and a chunk of code here and a chunk of code here, and they're all the same, what is that screaming out to you? Put it into a function. When you look at two different source files and you see, say, subscription ID and name, those are both in both products. Product ID and name. Right? I have constructors. We'll ignore the constructors here for a second. But I also have public double get cost in subscriptions and public double get cost in products. So when you've got duplication across different classes, that's screaming out to you to create a common class. That thing is called a superclass, and that's where inheritance comes in. So inheritance allows you to reuse a class by, and I'll use the keyword here, extending it and creating a subclass. In general, common functionality and state behavior is located in the superclass. All right? Specific behavior, right, or specialization is provided or overridden in the subclass. Just as a really quick preview here, what are the commonalities here? We've got a product ID and we've got a name. Those are the commonalities. We've also got this getCost function. So why don't I create a common interface for a common superclass for both of these things? Give me a name that means both product and subscription. Some generic thing, right? If I said, give me a name that describes an ostrich and a robin, you would say a bird, because they both are birds. What is a name that is, the product is that thing, and also a subscription is that thing? A what? The price would, it's not just a price though. A price is an aspect of these things. I like item. What else was there? Thing. You could call it object, except that everything is an object in Java. Thing, right? Or say what? Commodity? Okay. Commodity. If they're physical commodities, you could also have that's getting into too much finance for me. I'm a simple guy. I just like simple things. Item, right? Now, let's go ahead and take what's common to both of these things. I won't call it a product ID anymore. Instead, I'll call it an item ID and a name. And both of those things had public double getCost. Oops. That's my superclass. We're nowhere near done here, right? But this is a preview of what we're going to do next Tuesday. This is the commonality of both of those things. Now over here in product, I can say that it's a product that extends item. That means that I can get rid of those things that are already in the superclass, right? And we'll fix these later on Tuesday. I can also take these getters and put them up into the superclass. Right? We'll come back to fixing these later. But I can do the same thing to subscription, and I can get rid of the subscription ID and the name, and I can hoist up or bring these commonalities up to the superclass. The syntax again was extends. It extends the behavior. Right? And we have this hierarchy that we're starting to build here, where we've got superclasses and subclasses. We've got parent classes, child classes. Why do we like hierarchies? Because it's how we organize things naturally. Right? Again, we'll wait until next week to finish this off, because we do have the Writing Center coming in on Thursday to talk about design and drafting and technical writing.